Okay, so we're looking at drawing lights. Okay, what we need to know, or what we need to understand straight away is that when we look at light, we have to understand that light travels in a straight line. When light is emitted as a form of energy from a luminous object, it's coming out in straight lines. That means that it can be blocked. So if we put a whole bunch of light rays that are coming from a luminous object and then we chucked a blockade in front of it, we would only actually see two rays leading past it, and these two rays would be blocked by it, and therefore we would only see half of it. So that's light travelling in a straight line, and this is an object or a surface. So when light hits a surface, it can do one of three things. It can be absorbed, it can be reflected, or it can be transmitted. Now we're going to be looking at reflected and transmitted in this lesson. So what happens when a light hits a surface? So the red line is representing our surface. I'm going to start with a incident ray, or the ray that's coming from the luminous source. Our first ray pointing away from it, this is going to be called our incident ray. We can label that like this. When light hits a surface and it is absorbed, nothing happens. So we don't get any reflection and we don't get anything on this side. That is how we would draw it. Now if light's reflected, the light coming in is going to be bouncing off the surface, and we draw that with another line. But how can we predict or be sure of how the light is going to be coming off? Why doesn't the light end up over here, or why doesn't the light end up down here? Now what we do know is that there's a law of reflection, okay? And this is basic light properties, that the angle of incidence, the angle that this incident ray comes in, is equal to the angle of reflection, being our reflected ray. But where is our angle? Now our angle is going to be based on our ray and our normal line, which is given to us at 90 degrees from our surface. And so when we're looking at a different surface, we always need to have a different normal. So for example, in this one, this is our 90 degrees, this is our normal, and this is our angle that we're looking at. Now we're going to call this our angle of incidence. Now our angle of incidence is equal to this angle here, or our angle of reflection. We can use our equation, angle of I is equal to the angle of R. Therefore, if I is equal to 45 degrees, we'll know that the angle of R is equal to 45 degrees too. And that's reflection. But what happens when our surface is transparent, which means that the light can travel through? So if we got our light here and we continued it going so that it travelled through, what would happen if we put a different medium in front of it, something that was transparent, like glass or perspex? Now, we know that when light gets into a different medium, it's going to change speeds. So it's either going to speed up or it's going to slow down. Now, if we said that the medium that light was coming from was air, and the medium that it was going into was perspex, perspex has a higher refractive index, which means that it's going to slow down. It means that there's more resistance to the light, and it's going to slow it down, just like you would slow down in a car if you drove through a big puddle of water. So if we look at a table with refractive index where air is 1 and the speed of light in air is 300,000 kilometers per second, and we compare that to perspex where the refractive index is 1.49 and speed in perspex is 200,000 kilometers per second, the light has significantly slowed down. So what happens when light slows down? When light slows down, it's going to bend. And we know through testing and through experiments that the property of light is that when light slows down, it's going to bend towards the normal. Now we use the normal based on the surface that it's striking, so we're going to continue this one on. And the green dotted line represents our normal, and it's going to bend towards the normal, meaning that our predicted light, or our light that without a change in medium, is going to be bending towards this point here, or towards our normal. And we're we're going to end up with a line like this through our shape, where the arrow points how it's bent. And now what happens when the light is re-entering air? So it's going from perspex to air. Now it's going to be speeding up again. Now if we drew a predicted line of how the light would be if it wasn't changing mediums, and we took a new norm. Now the reason why we have to have a new normal is because we've got a new surface that our light is interacting with. It's changed from this surface to this surface, and we've got a new normal. So our new normal is represented by our green line here, and our light is going to be bending away from the normal, and our light is going to end up looking like this. So our predicted line has bent back away from the normal as it speeds up. And this is basically what our light diagram is going to look like as it enters a medium that is thicker or has